In this video, we'll be covering how layer height and nozzle size affects your 3D print and how to choose which one is best for your project. In the last video of this series, I covered the basics of Orca Slicer and how to use it to slice models for your 3D printer. Well, in this video, we'll be diving into the most important setting you'll want to tweak: layer height. The concept is pretty simple. All 3D prints are made up from stacks of layers, and by changing how thick these layers are, you can dramatically affect how the print is constructed and how it looks at the end. But the question is, what layer height should you choose? Well, it all comes down to a trade-off between print quality and print time. To demonstrate, I've got this hemispherical 3D shape and I've sliced it with a fairly standard 0.2mm layer height. That means each layer, each slice of this print is only 0.2mm thick, and this print needs 250 layers to be constructed. With this many layers, the print will take just under 2 hours to complete. But what if you wanted to speed up the print instead? Well, one method is to increase the layer height, which makes each layer thicker, so you need less of them to complete the print. So in this example, I've changed the layer height from 0.2mm to 0.3mm. This gives us 167 layers and a slightly reduced print time of 1 hour 45 minutes. If you're a bit confused as to why it's not closer to 1 hour 15, well, it's actually because the thicker layer height requires much thicker extrusion lines, and this means that the printer needs to extrude a much higher volume of plastic and melt it all at once. And 3D printing hot ends are only so powerful. So that means the printer actually needs to slow down a little to ensure that the parts still print successfully with the much coarser layer height. And along with this thicker layer height, you'll also notice that the top of the hemisphere looks quite bad indeed. This is because 3D printing is an additive process, and as these large layers approach the gentle curved surface at the top of the part, they effectively run out of resolution and can only approximate the desired surface. For curved top and bottom surfaces, like seen in this print, the thicker layers result in this unsightly stair-stepping effect. So then the obvious solution to improve quality would be to decrease the thickness of the layer heights instead. In this example, I've changed the layer height all the way down to 0.1mm. That's only a little thicker than the width of a human hair, and it results in a much nicer top surface for this print. The downside, however, is it needs much more layers, 499 in fact, and a much longer print time of 3 hours. It won't remove the artifacting on the top of the print entirely, but it sure does help a lot. However, you may have noticed that for the mostly vertical surfaces, even on the print at a 0.3mm layer height, that they still look rather good, and printing with a fine layer height here is pretty much a waste of time. So how about combining different layer heights instead to get the best quality possible while also shaving down print time? Well, with variable layer heights, you can. Variable layer height does exactly what it says on the tin. It lets you use different layer heights within the same model, and it blends smoothly between them. And that means we can achieve a really well-balanced print that only has really fine layer heights in the areas that it matters. To use variable layer heights, it's really simple. You simply select the model that you want to apply it to. Then at the top here in Orca Slicer, we have variable layer height up in the middle here. And you can apply variable layer height in two different ways. The first way is manually. So over on the right-hand side here, you can see that it's set at 0.3. That is going to be the coarsest layer height. And then if I click and drag, it'll gradually make that layer height finer in that area, and it shows a visual representation on the model. So if you have an area where you want to manually assign a much finer layer height to achieve more vertical detail, then you can do it this way. But this can be a bit tricky unless you know exactly what you're doing. So the easiest way is actually to just let it choose automatically for you. So I'm just going to hit reset, and instead I'm going to select adaptive. And with adaptive, the software will actually figure out where you need those finer layers, and it'll apply them in a smooth fashion like this. So with the defaults here, what it's done is it's actually printed most of the model at a very coarse 0.32mm layer height. And then as it gets to the top of that curve, it's decided to start reducing that layer height all the way down to 0.1, basically. But let's just say I want even more quality. I'll just move the slider a bit, and then I'll hit adaptive again. And now you can see it's spread those fine layer heights even further down that curved surface. You can see the visual representation here. It goes from a very, very fine layer height of 0.08 all the way to a coarser layer height near the bottom of 0.32 again. Variable layer heights aren't for every model, but for things like this, where you have large vertical surfaces and then a few gentle curved surfaces or gentle slope surfaces, they work really well, and they can mean you get a print that looks good and also doesn't take forever to print. But you might be wondering about layer height limits. How fine can you go, and how chunky can you make the layer height before it starts to fail? Well, that's where your nozzle size comes in. Filament 3D printers, known as FDM or FFF 3D printers, melt plastic filament out of a precision bore in the nozzle, and this is known as your nozzle size. Most 3D printers on the market today use a 0.4mm diameter nozzle, but they can go as small as 0.2 or as wide as 0.8mm or even larger. Your 3D printer's nozzle size will dictate the minimum detail that the 3D printer can resolve, but it's different depending on if the detail is on the top of the print or if it's on its side. Take this text for example. Drawing it on top of the print requires a very fine nozzle to make it look readable at all. It's effectively like trying to draw it with a super thick marker. On the side of the print, however, the text is built up from multiple layers stacked together. This gives you a better looking result depending on how fine your layer height is. Remember, a finer layer height will give you more resolution for the 3D printer to work with. In theory, there is no minimum layer height, no matter what the nozzle size is, but anything below 0.1 and you'll hit diminishing returns rather fast. But there is a maximum layer height for a given nozzle size, and it's roughly 75% of the nozzle diameter. You see, as the molten line of plastic extrudes from the nozzle, it squishes out slightly to a width that's determined by the extrusion width setting. Don't worry about that too much, but it's important to understand that your 3D printer isn't just laying down a perfectly rectangular cross-section of plastic. This means that if you try to print at a layer height of 0.4 with the same size nozzle, it can't form a nice accurate extrusion line. Instead, it will droop and dribble a bit, and you get these nasty looking squiggles and a terrible print. And this is why modern slicers like Orca Slicer simply won't allow you to set very large layer heights depending on your nozzle size, because they won't work. A good rule of thumb for maximum layer height is approximately 75% of the nozzle diameter. So for a 0.4mm nozzle, that would be 0.3. And for a 0.8mm nozzle, that would be a chunky layer height of 0.6. You absolutely can push the limits a bit and create some massive extrusion lines or layer heights, but that is fairly experimental and not something I would recommend for everyday printing. So to summarize, use coarse layer heights for rough, fast prints and fine layer heights for quality models with lots of curvy surfaces. Or you can combine the two to get the best of both worlds using variable layer heights. Use the cheat sheet linked in the description below if you get stuck, and you'll also find a link to our Patreon, which you should check out if you want to support more of these videos in future. Changing layer heights may speed up your 3D prints, but infill is a much more important setting when it comes to printing faster and saving filament. So in the next video of this series, I'll be covering all the different kinds of infill you can use and how to choose which one is perfect for your prints.